Hello and welcome to our latest edition of the Virtual Bridge Sessions. And today I'm joined by with Rebecca Blyth. With and by, I always get those prepositions wrong, which is embarrassing given that I used to be an English teacher. But anyway, today's topic is about engaging young learners with STEM, and that's something I'm fascinated with because as a young boy, I grew up in the sort of era of Clive Sinclair and his Sinclair Spectrum, because I'm old. And, I was fascinated. The first time I got a computer, truthfully, all my friends could afford the Sinclair Spectrum. I had a VIC-20, and it was basic, to say the least. But I was fascinated by the magazines I used to buy every other week and just type in endless lines of code to see things happening on my TV. The idea that I could create something that actually meant that it appeared on the TV was just brilliant. I know that won't mean anything to you youngsters who had like other screens to look at, but literally we only had a TV in our house, and the fact that I could do something on it just made me want to learn more. And so that's why, Rebecca, I'm fascinated about the projects at Fife College, virtual coding academies, engaging young learners. I just want to learn more.
That's brilliant. Thank you, Kenji. So welcome and thank you all for joining us this morning. The aim of this session is to provide you with an insight into how at Fife College we have been engaging young learners into STEM-related activities. I've got 3 projects I'll be talking through today, but before I do this, I'll just introduce myself. So my name is Rebecca Blyth and I'm the Academic and Quality Manager for Computing and Technologies at Fife College. Now, we've been working in partnership on these projects with Fife Council, in partnership with Alison St Clair, who's from the Culture of Enterprise Department. Unfortunately, she can't be here with us today. However, there are some slides that relate to the Culture of Enterprise, and I'll be reading out on her behalf today. So I think, Kenji, if you could kindly screen share for me today. Brilliant, that's great, thank you. We're just going to pop on to the next slide, which is just a sort of overview of STEM or STEAM. I'm sure you've heard of this before, but it's about how this relates to the activities that we're trying to provide to young pupils. So it's a quick overview. So it's an approach to develop and prepare primary and secondary pupils for college or university in a variety of different areas, such as science, technology, engineering, arts and maths. And arts has been quite newly added to the STEM, which means STEAM now. Okay, if we could now move on to the next slide. Okay, so there's a number of initiatives as to why we're trying to embed STEM within primary schools and also into secondary schools. There's such a big focus on this, and some of this relates to the STEM education and training strategy, which was published by the Scottish Government in 2017, which aims to inspire young people and adults into STEM-related activities. I would say that there is a lack of awareness of what STEAM is, and this stems from embedding it into the curriculum at a young age. So what we're trying to do is provide new technologies that young pupils have never engaged with before, make sure it's fun, exciting and engaging for them, and also linking it to exciting future careers as well. So skills for the future and what we're trying to build upon. You've probably heard of meta skills before as well. So although we're providing these fun and new activities for our young people, we need to build on the pupils' meta skills for their futures. So this relates to the SCS diagram in front of us here, where we're trying to build up young learners' confidence within meta skills in all aspects of critical thinking, communication, collaboration and adaptation. Now the next diagram just below, which shows a sort of pathway and a journey throughout education. So at the moment we're focusing on P5 to P7, and I think it's a brilliant reflection of where we're trying to go and what we're trying to do. So this clearly shows the pathway we're trying to follow and why we're doing it. So by influencing STEM-related activities at a young age, we're building upon these skills at high school, and then progression to either college or articulation into university, and then finally into the workplace. Okay, so the first project I'm going to go over today is the Virtual Coding Academy. This is aimed at 9 to 12-year-olds, and the Virtual Coding Academy, how it works, if we could go on to the next slide, Kenji, thank you, is about providing different programming languages and how we set these up for pupils to interact with. So the Academy was first set up as an on-campus activity in 2019 as an after-school club essentially, but then COVID hit, which meant lockdown and no Academy. So we kind of fell by the wayside in terms of our engagement with primary schools. However, we quickly saw there was a window of opportunity to publish these activities online. Okay. So how it works is the course is designed to introduce learners to a variety of scripting languages, including Python, HTML and CSS. Now these are all the sorts of programming skills that pupils will need for at high school, whether they select higher computing science, National 5, these are the sorts of programming languages that they'll build upon. So it's good if we start to embed that at a young age and make them aware of what this is. Okay, so the breakdown of how the Coding Academy works is teachers are supplied with weekly materials for pupils to work through. Every 3 weeks there's a homework activity which allows pupils to source an asset, a photo which could be included in a game or decide on a topic for the following week. Every 8 weeks there's also a show and tell aspect which allows people to showcase their work, and teachers have the option to decide if there is going to be an in-class competition too. So we're trying to build up their confidence there. So the success of the Virtual Coding Academy, we didn't expect it to take off as it did, but it shows a real need for these sorts of activities at primary school level. So in 1920, we only had 20 primary school pupils take part on campus. Last year, by making it virtual, we had 1,000, and this year we've doubled it to 2,000 pupils taking part across Fife, which is fantastic to see. And I've included just a photograph here of one of the primary schools, which is St Seraph's. They are one of 20 primary schools taking part this year. Now, how this links to culture and enterprise framework. So this is from Alice St Clair and how it relates to her framework. So the framework for culture of enterprise aims to foster a culture which both values and encourages enterprise. So enterprise skills are crucial to support young people into positive destination. And I think this actually really relates back to the meta skills that we're trying to build on. So by working together and collaborating on this, we're both looking at the same end goal. Now, the 3D printing project is our second project that we've been working on over the last couple of years as well. Again, it's aimed at primary schools, 9 to 12-year-olds. So how it works is this course is delivered online over 16 weeks, focusing on drawing, designing, printing and modelling the 3D models. There's an example of what pupils can build, which is a keyring, or they can build a character if they're looking to do that. There's 8 tutorial videos which are provided, and teachers and pupils get at least 2 weeks to carry out the activities within that tutorial. We also aim to use resources and software that's accessible to schools, so it's free for anybody to use. So we use the software called Tinkercad. Okay. So a breakdown of how this works is that we actually loan out 3D printers to primary schools on a loan basis between myself and Fife Council. Last year we actually only had 8 printers between us, which meant only 16 primary schools could take part across the year. And what Alison does on her side is she communicates with the primary schools before summer to find out how many primary schools are looking to take part. This year we've seen at least 40 primary schools asking to take part, which is over and above what we could provide. However, we realised we had to upscale our facilities and the number of printers we had. So between us, we've managed to purchase 8 each, which means that 32 across the full year can take part. So we now have essentially doubled our aspect of this again. This allows primary schools who do not have 3D printers to take part, but it's also really encouraging to see that more and more primary schools are buying their own. So we've had this year some primary schools come to us and say, we'd like to take part, but we've actually bought our own 3D printer. So we'll still use your resources and videos, but we see the worthwhile in using a 3D printer and how it relates to industry. So some further learning there, we try not to stop there with just our introductory videos for the 3D printing project. So what we try to do is provide some further learning resources, and this could be about using 3D pens, different and more advanced software to complete or create more complex and intricate models there. So that's just some examples of further learning resources we also try and provide. Now, what we're really keen on doing is linking these sorts of activities with industry so that people see the benefits of why they're learning these skills and also how it relates to careers in the future and the sort of progression routes that they might want to go down as well. So we reached out to some local businesses to ask if anybody could supply us with examples of how they use 3D printers in their business or line of work. So Peachy Keen is one example of a company that came forward. They provided us, or kindly provided us, with an example of how they use 3D printers in their workplace. So they're a human energy business, and they've created a short video that Kenji is just about to show us.
Here is a pulley manufactured on our super duper Zortrax 3D printer. Now this has been 3D printed in approximately an hour and a half. All it's required us to do is design it on the computer, send it to the machine, and hey presto, we've got this lovely pulley. In the past, we would have had to use a machine like this, which has got a lathe and a milling machine. We would take a rod of metal like that. Then we would manufacture it using subtractive processes to give the grooves that you see around the rod. And then when we're finished, we would cut it to length and we'd have something similar to what we did in one process on the printer. On the left here we have aluminium, which is subtractive manufacturing, where we remove the material to create the middle object, which is a pulley, is the finished article. And on the very right we have our 3D printed example, which just requires additive manufacturing on a printer. Okay, here we have a finished pulley for one of our devices, and you can see it looks solid, so it was made out of one piece of plastic or metal. But actually it's been produced with a 3D printer, and that's what it looks like inside. So its density is about 20%, it's made up in layers. And actually the pattern here is pinched from nature. You'll find this in many plants, and it's structurally stronger. It means we use less material and enables us to get a finished article that's as strong as if it was made out of solid plastic or metal in this case. Now just to finish off, what we have here is examples of 3D prints that have been manufactured in one process, but they're moving parts. For example, we've got a little wheel here, a wee fidget, and then we have these little gears here. And just for fun, we have a pair of scissors. So this was printed as one part. There were supports around it, and all you do is remove the supports, and you've got a working article, in this case, to have fun with.
That's okay, don't worry. That video is actually embedded into the 3D print project, so the pupils and teachers can display that in their classrooms and show how it contributes to the workplace. Okay, so STEM 3D printing and enterprise. So again, going back to Alison Sinclair at Fife Council, so fostering logic, creativity and problem solving skills. These are some of the key areas that we're trying to focus on. We're also trying to provide young people with practical experience within high growth sectors. So these areas are expanding and evolving all the time, and there's a lot of job opportunity as well. So we're trying to embed that at a young age as well. Again, here's just some fun photos of Dulwich Primary Schools taking part in the project. So again, some pupils can create the characters, and some other pupils can work on the software there using one of our printers. Now, the last project that I'm going to go over today is one of our most recent projects that we started on in March this year, and we finished in April. It's an introduction to Raspberry Pi, and it's aimed at 14 plus this time. So we're looking at high school level, which is the next step that we're trying to take. So this project is actually in collaboration with Raytheon. As you might be aware, Raytheon is a technology company focused on defence, aerospace, cyber and intelligence, with many sites across the UK. Now, Raytheon actually wanted to give back to the community, providing high schools in Fife with numerous Raspberry Pis. However, it became quite clear quickly that although we were providing high schools with these devices, there wasn't any real knowledge or experience about how to use Raspberry Pis from an education perspective. So that's where Fife College came in. Okay, so what we did was we actually came up with an introductory course with 6 weekly tasks, tutorials, projects and surveys fully online, building up skills in Python and using Scratch. So at a bit more advanced level from primary school, but still at introductory level. So enough knowledge to be able to allow the pupils to take part and actually build projects using the Raspberry Pis. Now again, we collaborated with Raytheon, and Raytheon were excellent in providing us with a short video clip on how they use Raspberry Pis within their workplace.
Hello, my name is Scott and I'm a STEM ambassador with Raytheon UK. Today I'm going to be discussing some practical applications for using Raspberry Pis in the workplace. To give you some context, here's a little bit of information about what we do. Raytheon UK is one of the leading manufacturers in aerospace, intelligence and defence. We work heavily with the US and UK government to design and manufacture all the electrical components that go into things like radars, electrical and mechanical systems and drones. You might know us from doing activities around schools with our STEM ambassadors, like the Quadcopter Challenge that we started in 2015 that takes place all around the UK. Within our STEM events, using Raspberry Pis could help us make the QB and robotic arm activities more portable. They would also open the possibility of making new activities, since the Raspberry Pis are very easy to program on. So one of the most important applications of using Raspberry Pis is how it plays into Industry 4.0. But what exactly is Industry 4.0? You can think of Industry 1.0 as the introduction to steam power to make textiles and clothes. Industry 2.0 introduces electricity into mass production. This is around the time all the railways were built. Industry 3.0 uses computers to automate processes. This is kind of where we are right now. And now Industry 4.0 is connecting all the machines through the internet to collect data. You can also refer to this as the fourth industrial revolution. At Raytheon, we manufacture all of our circuit cards with a line of machines connected with a conveyor belt. The job of these machines is to solder the components onto the circuit cards and then make sure that the solder is the right amount and is bonded to the components and the board properly. How could Raspberry Pis help the production line? So this is what the production line looks like. This first one hasn't been through any machines, this second one has all its components, and this pile at the end are complete and ready to send to the customer. Right now, all we know is whether the product has been through or not. This is where Raspberry Pis get involved. Due to its size, capability and low price, the Raspberry Pi can be connected to a variety of sensors and can be used to monitor all of the machines to collect a lot of information. The Raspberry Pi is easily programmed to whatever is required and can also send that data through a hardwired Ethernet or through Wi-Fi. Through this, a digital twin of the factory can be made so that engineers at their desks can see exactly what's going on in the factory. They can also use this data from the Raspberry Pi to forecast the production schedule and detect any issues that happen. We at Raytheon are just starting to implement Industry 4.0 practices in the factory. Many car companies like Ford Motors already have some automated processes like this. With some kind of workflow analysis, you can see that machine 2 is slowing down and creating a ripple effect through machine 3. With the Raspberry Pi, you can see a lot of information, and then in turn, you can solve the problem before a machine breaks down. As you might know, the Raspberry Pi has a lot of development environments, or IDE, built in. This helps our ID development create all the software that we use. And finally, performance boards. This can indicate to everybody in the factory how the day is going and how productive they are. Using a PC for something so simple would be overkill. Thank you for watching. If you have any questions or queries, feel free to contact us at the email on the screen. Goodbye.
Okay, so again, another great example there of how we're linking this with industry, especially from Raytheon's perspective, how they use Raspberry Pis in the workplace, and again, it's embedded within the project itself, so the teachers can view it and also the pupils as well. Some key takeaways then to wrap up these projects is that we have overall improved opportunities for young people, or we're trying to, something that is we are continually working on. We've got around 20 primary schools taking part this year, and overall across all of the activities, we have around 3,000 pupils taking part. So it's excellent to see that there is such a demand for these sorts of activities. And it's about how can we improve them and keep this going as well. Gender balance, I think it's quite difficult to try to improve gender balance and keep that up as well. So what I would say is all these projects are open to anybody to be involved in, so all pupils can engage in any of the activities. And I think further improvement could be made either through case studies or looking at different types of engagement. Linking technologies with computing and industry, again, that's something that we're starting to look to do with local businesses, and we're also trying to embed the meta skills throughout all of the activities. So we're building and encouraging pupils with these skills to progress onto high school and then onto college and university, and then finally into a positive destination. So thank you all for listening today, and I'll open the floor for any questions. Thank you very much, Genji.
Okay, so I just have to apologize. I'm like the worst assistant ever with slides.
Not at all.
Thanks,
Not at all.
thanks for that, Rebecca. Yeah, let's open the floor to questions. I'd like to start with one, and that's really about. It's amazing what you're doing, and the number of pupils that you're reaching through this program. Those numbers, 2,000 in this current year, is just a fantastic figure. Oh, one of the things I want to ask is, we know that there is somewhat a lack of computing teaching skill within the school structure. And so by reaching out to so many primary schools, and I know teachers do a wonderful job with my own kids in their primary school as well, but at the same time, they definitely need some support around getting to grips with the technology, having confidence to teach these skills to their pupils. So what kind of things do you do to support the teachers to deliver this part of the curriculum?
Absolutely, I think you're spot on there, Kenji. Not only do we provide the activity, but we do put on some CPD sessions for teachers before they start the project. So we just had a couple of days there in August where teachers were able to come along virtually on Teams and speak to subject matter experts or lecturers that either work with Raspberry Pis, programming, or speak to our lecturers within 3D modelling and printing, and also the setup behind the activities. So that's something that's ongoing and we do try to provide each year.
I see there's a comment there in the chat from Walter, and he was talking about surprised that there was no experience of the Pi in schools. There's no shortage of tutorials, projects, computing at school, etc. And the Raspberry Pi Foundation newsletters. And just from my experience, I know there is a wealth of material out there, and there are a lot of projects. But I think what you said strikes at the heart of the thing, is that as a teacher with not much digital experience, you really need that one-to-one support, somebody to talk you through what it is. A lot of people do have the confidence to go online and just watch the tutorials, but I think there's an issue there. What do you think, Walter?
Yeah, of course, at the root of this may be some of the issues that different local authorities are having in sustaining computing teacher numbers in their schools. So there's a whole lot of factors that might play into this. So I think we can only applaud the work that Rebecca and others are doing to give that additional support and to point people to these resources. Thanks, Rebecca.
Thank you.
So Rebecca, you've got short compressed courses there, tasks, homework tasks, things that the students can get involved with. For the primary schools, do you get a sense of they want more now that you've teased them with something there? So
yes,
how do you respond to that demand?
Absolutely, I think you're right. Myself and Alison actually have a meeting in a couple of weeks' time with Education Scotland to see how we can upscale it to the southeast, and they're potentially looking at it nationally as well. Obviously there's a lot of logistics behind that, but there is obviously some massive demand behind these activities, that we need to provide more of these activities to primary schools, especially at that level. If we encourage it there, then we're also encouraging it into high schools as well.
And again, we'll probably have time for another question or two. So Janet, Jamie, if you want to jump in there, and just before you do, what's the feedback been like from schools, of the pupils and the teachers that have gone through these projects?
It's actually been really encouraging to see that pupils engaging with these sorts of opportunities. We receive video clips and often photographs of the pupils taking part and the projects that they come up with as well. So it's really good to see the amount of engagement the pupils do have within the activities, and also the teachers are enjoying it themselves. That's also one of the main aspects too. This
is a personal curiosity. There are so many 3D printers out on the market. How did you choose the printer to give to the schools? Is there a particular thing? And did you give them advice when they went to buy their own?
No, well, yes, within the further learning section, we do provide some aspects on what printers are best suited, especially at primary school level. You've got to think about the health and safety around it. You can't just have a printer that's open and it's not enclosed. So we've often went for a printer that's enclosed, and it works on just a reel of recycled plastic that obviously goes through the printer and prints out the model. So we try to go with a printer that doesn't need much setup. It's just about installing the software, or sometimes doesn't even need the software, and then it's just able to be printed. So we try to look for the one that's the less confusing, the better, basically.
And are there any challenges that you've had to overcome during this project period? Things that you didn't think of but sort of appeared as you went along, and how have you dealt with those?
Yeah, definitely. I would probably say, going back to the first point about CPD for teachers, so although we were initially, obviously this is something that we've been working on over the past 3 years, although we provided the activities to the teachers and the pupils, and also dropped off the printers, we then realised that we actually need to be there either to set it up or show them how to do this, and also be there in the background to enable that support for them as well. So that's something that we're working on, and also we've been embedding videos on how they can set it up and purchase their own.
I see, Jamie, you have a question, and we have time for just one last question. So Jamie, if you want to unmute and ask yourself.
Yeah, it's good to see obviously these age group of pupils being trained in the tools that they'll be using in industry and in the workplace. Obviously 3D printing is just one, and the Raspberry Pis is another example, but is there any plans for more of this type of vocational engagement and training on the tools for the job, or is it currently just the Raspberry Pi and the 3D printer at the moment?
So at the moment, those are the projects that we've worked on over lockdown, and as we're starting to move out of that, we are starting to look at more high school engagement, and currently we're actually looking to go out to high schools in Fife and offer workshops within computing and technologies, so within computer games design, within cyber networking, just little snippets of what pupils could engage with in employment, and linking it with employment as well, and future careers. So we are trying to now expand on that and move away from these sorts of activities and include more in the future.
Well,
it's great to see the employers are so forthcoming and not have to be chased rather than by the college kind of thing. So
I think that's one great point that you've made, Jamie, about the idea that Rebecca, that you managed to bring industry into that conversation, even at such a young age. And I think it's just that spark to give them the imagination and the idea that this is something that they could do. And the fact that they've got practical activities where they can actually see that creation happen for themselves. It's just what you need. Again, going back to my Vic 20 and when I started typing out those lines of code. Which I always got wrong. Right. Now, I have to bring this session to an end because we've come to the end of our recording time. And more importantly, my kids are demanding that I take them to a pumpkin patch to pick pumpkins. So I can't be late for that. Thank you so much for the presentation, Rebecca. And thank you, everyone, for joining us today. And if you're watching on YouTube, hopefully you'll get a chance to join us live in one of these sessions in the future. But until then, as always, stay safe.